Hi, welcome back. And thank you for your patience as we have navigated some technical challenges with getting Dr. Volkow connected. But alas, we have been successful, and she is able to join us today via audio. I'd like to introduce Shelley Mowry, who is going to be introducing Dr. Volkow. Shelley Mowry sits on our ADAPT Advisory Council, and she is the Demand Reduction Coordinator for the Arizona HIDA.
Thank you, Dr. Adams, for your incredible leadership in public health and for your investment in critical partnerships that help facilitate effective substance use prevention. My name is Shelley Mowry, and I'm the Demand Reduction Coordinator for Arizona HIDA. I also sit on the Advisory Council for ADAPT. It is now my great honor and privilege to introduce Dr. Nora Volkow, the Director of the National Institute on Drug Abuse at the National Institutes of Health. Her work has been instrumental in demonstrating that drug addiction is a disease of the human brain. As a research psychiatrist and scientist, Dr. Volkow pioneered the use of brain imaging to investigate the toxic and addictive properties of substances. Dr. Volkow was born in Mexico, attended the modern American school, and earned her medical degree from the National University of Mexico in Mexico City, where she received the Robbins Award for Best Medical Student of her generation. Her psychiatric residency was at New York University, where she earned the Laughlin Fellowship Award as one of the 10 outstanding psychiatric residents in the United States. Most of her professional career was spent at the Department of Energy's Brookhaven National Laboratory in Upton, New York, where she held several leadership positions, including Director of Nuclear Medicine, Chairman of the Medical Department, and Associate Director for Life Sciences. Dr. Volkow was also a professor in the Department of Psychiatry and Associate Dean of the Medical School at the State University of New York, Stony Brook. She has been the recipient of multiple awards. She received a Nathan Davis Award for Outstanding Government Service, was a Samuel J. Heyman Service to America Medal finalist, and was inducted into the Children and Adults with Attention Deficit Hyperactivity Disorder Hall of Fame. She was elected to membership in the Institute of Medicine in the National Academy of Sciences and into the Association of American Physicians. She received the International Prize from the French Institute of Health and Medical Research for her pioneering work in brain imaging and addiction science, and was awarded the Carnegie Prize in Mind and Brain Sciences from Carnegie Mellon University. She has been named one of Time Magazine's top 100 people who shape our world, one of the 20 people to watch by Newsweek magazine, Washingtonian magazine's 100 most powerful women in 2015, 17, and 19, Innovator of the Year by U.S. World and Report, and one of 34 leaders who are changing healthcare by Fortune magazine. We are extremely fortunate to have her with us today. Please join me in welcoming Dr. Nora Volkow.
Dr. Volkow, you're on.
Good morning, everybody. I'm Nora Volkov, and I'm the director of the National Institute on Drug Abuse, and I want to thank HITA for giving me the opportunity and ONDCP to speak about the science of prevention in substance use disorder. So can I have the first slide? I want to start, actually, my presentation is going to be very much focused on the children and adolescents because they are the most vulnerable for experimenting with drugs. And if they do experiment with drugs, they are the ones that are more likely to have the most adverse effects. That does not mean that prevention is not relevant to all adults. It also is. But the largest impact pertains to the vulnerability of children and adolescents. And so I want just to start by getting a perspective of what are some of the challenging issues that we face on drug use, in patterns of drug use among teenagers in our country. And what we have seen, which is on the right side, is that there's been a significant decrease in the utilization of legal drugs among teenagers. Very abrupt, actually. To your left, for example, you have the cigarette smoking past month indicator, and you can see what a dramatic decline there has been over the past 10 years. And you see data for the 8th, 10th, and 12th graders. This is information that comes from the monitoring the future. And you can see the lowest levels of smoking that we've ever had since initiation of this survey. Similarly, though not as dramatic, but also very positively, we've seen significant reductions in drinking behavior among teenagers. And these drinking behavior, the reductions are not just for occasional social drinking among teenagers, but also with the most dangerous behavior, which is binge drinking. Again, the effects are significant for all of the age grades. So this is very important because this, in general, tended to be certainly alcohol, the most frequently used drugs by adolescents. However, unfortunately, despite these advances, particularly in cigarette smoking, see what happens in the next slide. Can I have the next slide? With the entrance of electronic cigarettes into our society, adolescents have embraced them like we have not seen any other age groups. And so very, very rapidly, we have seen an escalation of the utilization of these devices for administering to the left nicotine or for administering to the right THC. And now THC is the active ingredient of cannabis. So it's the one that makes you high, it's the one that has the highest addictive effects. Let's start with nicotine. And nicotine, you have the daily nicotine vaping that you observe in 8, 10, and 12 graders. Now, this is daily nicotine, and you can see now that 12% of 12 graders are stating that they are using nicotine in a regular basis. And that is actually increased from almost non-existent over a period of 3 years. And you can see how rapidly the uptake of nicotine is. For the indicator, nicotine patch bound, the numbers actually show that 1 out of 4 12 graders and 1 out of 5 10 graders has actually consumed nicotine this way. Now, nicotine is a very addictive drug, and we can foresee that these kids that are taking nicotine regularly are going to very likely become addictive. And the data is already showing us that this increases the transition into combustible tobacco with all of its associated ill health effects. Irrespective of that, we know that not only is nicotine addictive, but nicotine, particularly during these early stages of brain development, has significant effects to the brain. Similarly, look at THC, very, very dramatic increases in vaping of THC in a very, very short period of time. And this is also of great concern because when you vape THC, the content of the drug is much greater than when you smoke a joint. And the same is true for nicotine. The content of nicotine is much greater in these vaping devices. And this then turns into a greater risk of becoming addicted and a greater risk for adverse effects, which is what we're already seeing both for nicotine and THC. Now, how is that impacting the overall exposure of teenagers to THC? And let's now focus on THC. Next slide. And what we saw last November, December, when we had the report of the Monitoring the Future, which actually escaped me until I saw it 1 week later, was that we have an increase in the most dangerous pattern of cannabis consumption, or THC, and that is the regular use. And we have seen increases, significant increases from 2018 to 2019 in regular use of cannabis in 8 and 10 graders, and there were also increases, though this did not reach significance, among 12 graders. But you can start to see that 6.4% of teenagers, and these are school-age teenagers, which means it's likely to be an underrepresented representation of the prevalence of regular use of THC, since the use of regular THC is associated with dropout of schools. Now, why is this worrisome? It's worrisome because we know that the regular use is the one that leads to higher risk of becoming addicted to marijuana, but also the use of marijuana early on increases the risk of addiction to other drugs. And when you look at also in the context of the products of marijuana currently available to teenagers to consume, you start to get very worried. And that is because, as we know, the content of THC in the cannabis plant has significantly increased over the past 15 years. And we also know that the higher the content of THC, the greater the risk of addiction, but also the greater the risk of toxicity associated with THC, including the greater risk for adverse psychiatric disorders. Now let's look at the next slide. This is an old slide that clearly shows why we are concerned. Next slide. This slide first brought in, if we can pass the next slide, this one actually showed why the use of THC, particularly at high content THC and regularly, can be so detrimental for young people. And this is because THC acts, its mechanism of action, it basically takes over our own endogenous cannabinoid system. And the endogenous cannabinoid system is very ubiquitous in our brain and in our body, and it serves many, many functions. But in a developing brain, the endogenous cannabinoid system plays a key role in the development of that brain, including, for example, orchestrating the migration of neurons, creating connections with neurons from one another. And this it actually produces by stimulating cannabinoid receptors. Now, THC stimulates these cannabinoid receptors outside of any developmentally very well orchestrated process. And thus one can postulate that this is likely to be very harmful. And these brain images, what they showed, and this, even though this is an old study now, but they very, very nicely indicate how it can be deleterious. It indicates the connections between different areas of the brain. And the brain is the most complex network that you can think of. It's actually a networks of networks of networks. We're processing information at multiple sites at the same time, dividing it and then integrating it, again, in a dynamic form. For that to function properly, you require the connections that will make this possible. And what this study showed that was in young adults who had a history of heavy consumption of marijuana during adolescence, there was a profound decrease in the connections in several key structures of the brain, including, as you see here to the left, the connections that actually go into the hippocampus. And the hippocampus is a fundamental structure in our brain to enable us our memory. But the hippocampus is also important because it is involved in regulation of stress responses, as is the case also of the amygdala. And in this particular study, they show that the greater the consumption, the years of consumption of marijuana, the worse the disruption of those connections. And this is exactly why we are concerned about the potential negative effects of cannabis, particularly in the developing brain. And now we're trying to understand how this process comes about. Why is it that you have reduced connections? And those studies can be better done in adults. So in the next slides, I show you findings from two studies that actually are looking at two different processes that have been postulated that are relevant to the adverse effects of marijuana into the human brain. One of them relates to the fact that THC may promote neuroinflammation, and by promoting neuroinflammation, it can damage circuits and it can damage cells in the brain. And in this particular study, you see that individuals in blue, which are people that have a cannabis use disorder, versus individuals in black for different areas of the brain, where you are actually measuring a marker of inflammatory responses. And you can see how throughout the different areas of the brain, individuals that are consuming cannabis have a much higher signal of inflammatory responses. And this is likely to, even though this is in adults, this is also likely to be happening in adolescents. And to the right, you see a more recent study, which actually is able to document the proteins, expression of the proteins that are necessary to form a synaptic connection. Now, normally when you are learning something, you have to form and strengthen a synapsis. So these proteins are fundamental. Without them, you cannot actually modify your brain as a function of the experience. And what you see here is in blue are the individuals that are controls, and in red are the individuals that have a cannabis use disorder, again, in the hippocampus. And you can see that the synaptic expression of this protein, which is a reflection of synaptic density, of connectivity, is significantly reduced in cannabis users. Now, you translate this not into an adult whose brain is much more developed than ours. It still has to change, because otherwise we wouldn't be able to learn from experience. But the level of plasticity of a young brain is much greater and much more important at that stage of your life. And so one can see why the use of marijuana and THC exposure is likely to be so deleterious for young people. Next slide. And move it, because this is a dynamic slide, so I want all of it. The next one, move. Yes, yeah, keep it there. What we're trying to understand is, in framing all of this, we know we're starting, of course, to understand much better how drugs affect the brain mechanisms, and we focus a lot on understanding addiction because it's very, very devastating. But we also need to recognize that sometimes just the effects of drugs on the brain by themselves are going to be very negative, even though they may not necessarily result to addiction. But addiction is actually one of the most severe manifestations of the negative effects of drugs in the brain. And there's been an enormous amount of research to understand why some people that get exposed to drugs become addicted, whereas others do not. And there's also been years and years of epidemiological research showing that the environment where someone is exposed, where someone is actually rose up in, are fundamental in determining your risk for becoming addicted. So we know that the environment, particularly the social environment in all of its complexity, can act either as a protector that can build resilience to taking drugs and to become addicted, or can make you vulnerable for drug experimentation, and once you experiment into drugs, to transition into addiction. But we also know that your genetics also plays a role. And we know that because there's been studies that have actually assessed the risk of becoming addicted to alcohol, to nicotine, when you have a family history of addictions, and have shown unequivocally that if you come from a family with a history of addiction, even if you are actually separated from your biological parents and reared by adoptive parents, your risks are still very high, as if they were being reared by the biological parents. So we know genetics are fundamental. And we know it is likely that genetic environment interaction that drives our vulnerabilities and resilience for this addiction, but for also other disorders and also our traits. And as I mentioned, very important for addiction is developmental stage. The younger you start taking drugs, the greater the risk of negative effects and of addiction. So let's plunge into what we know from some of the studies. Next slide. So research now enables us to ask that question. Well, we know that the vulnerability of the resilience to become addicted is very much determined in your ability, your brain, your reaction to an environment. And so the question is, how do we know how the brain is affected by my genes in ways that can make me vulnerable versus how is my brain affected by the environment I grow up to make me vulnerable? And so you see to the left brain images from children of different ages, from 5, 8, 11, 14, and 17 years of age. And the colors represent changes in the structure of the brain, and you can see how it's changing throughout all of those processes. In the lower part, though, what the researchers have done is separated the changes throughout those developmental stages that are accounted by your genetics in the upper row versus those that are accounted by your environment. And you can dissect these two contributions by comparing comparing similarities and differences between identical and non-identical twins. Identical and non-identical twins basically very much, particularly during the first few years, share the same environment. But they differ in that the identical twins have the same genes versus the non-identical twins do not. They share a certain percentage, but they don't have the same genes. And so by doing this type of studies, you can actually determine the contributions of genes in the upper ones and environment on the lower ones. I just want you to concentrate on the environment overall, because it tells us that the greatest influence on how the environment affects the brain is most prominent when we're very young, 5, 8, 11 years of age, and much less so, and that's why it's blue, in 14 and 17. Whereas on genetics, you see a strong influence, yes, during the earlier stages, but you still see how at age 17, there are several areas of the brain that are still influenced by our genetics. Now, what does this tell us? It tells us that the period of greatest vulnerability as it relates to the effects of the environment, whether it is positive or negative, is during childhood and early adolescence. And again, highlighting why we want to provide environments that are going to be protective to provide resilience and strength to those children. So in terms of what is it that we know in neurocircuitry that will provide strength and resilience towards substance use disorder or mental disorders, we know that there is an interplay that is very, very important that relates to the differential level of development for limbic areas of the brain versus prefrontal regions, which is the schematic to your right. And the limbic brain is basically developed much, much faster than the prefrontal regions. Limbic regions, of course, it is crucial that we have them develop very early on because it will allow us to create emotional attachments. It will allow us to react to our environment and to motivate our actions. The prefrontal regions, on the other hand, allow us to do abstract thinking, to start to understand and regulate our desires and emotions. And it is the difference in the rate at which these two important systems in the brain form that actually becomes a major challenge and a target for interventions to provide resilience. We want to ensure that there is proper development of prefrontal regions in order to provide that individual the capacity to self-regulate. So what do we know right now as it relates to the adverse environments that have been consistently shown to increase the vulnerability for substance use disorder? How do they affect this evolution of the brain, both the prefrontal regions as well as the limbic area? Next slide. The importance of adverse childhood experiences has been replicated multiple times. It is factual. We don't need to corroborate it again. And what these studies have shown is that children exposed to adverse environments have a linear increase in also becoming addicted, depending on how many of them they've been exposed to. Now, what are some of those adverse childhood experiences? Abuse, emotional, physical, sexual, neglect, again, emotional, physical, household dysfunction, father, mother, parental separation or divorce, mental illness in household substance abuse, incarcerated household member, and low socioeconomic background. All of these significantly increase the risk for a child to become addicted. And now what investigators have been doing is trying to understand why. Now, we do know that not all of these adverse childhood experiences are the same. They affect the brain in different ways. But overall, we have a very good idea about why now in the brain they have adverse consequences. So let's look at the next slide. The next slide is a study that has actually continues to go because they're following these children that were born in an orphanage in Romania. And they've been studied and looking at the connectivity. That's what we see right in front of us. The connectivity of their brain as a function of the years that they've been in the orphanage. And this study became a classic because they actually were able to indicate that the longer these children had been in the orphanage, the greater the atrophy of their brains, much less development. And what you see there in red, actually specifically the connectivity I was discussing before that marijuana interferes with. Well, social neglect, deprivation, also results in improper connections of the brain. And again, I'm highlighting connections that are linking with the hippocampus and the amygdala, which are relevant for memory, learning, and for emotions. So you can start to see how these factors could get confounding with one another. And some of these connections are actually crucial for interacting between the prefrontal cortex and the limbic brain. And those connections are fundamental for us to be able to regulate our emotions, which gives an explanation about why children that are born in social deprivation are much more likely to be impulsive and to regulate their emotions. The next slide, actually, this is a study, and the next slide, look at, it's not done in humans, it's non-human primates, and I do want to say, of course, the complexity of the human brain and the social systems is much greater. But by studying sometimes animal, we can understand because we can control variables much better. And this study captured my brain because it actually indicates how devastating social isolation is for the human brain, as well as the brain of a non-human primate, as is the case. And in these particular images, what you're measuring is the proteins, D2 receptors, that actually mediate rewarding effects of drugs and mediate also your vulnerability to addiction. The lower the levels of these receptors in the brain, the greater your risk of becoming addicted and the more severe the addiction. And what these investigators showed was initially they had monkeys, and you see them who had been reared all of their childhood in individually housed, isolation, very, very stressful. And then they bring them into a group environment and they observe what happens to the receptors. And some of them became dominant in green, and some of them became subordinate in red. Very stressful to be a subordinate. And what you can see when you look at the receptor levels in the individually housed, very low levels of receptors, which actually can predict high vulnerability for drug taking and also for escalation of drug taking. But when you take those animals and put them into a group environment where they become actually dominant, the receptors go up. Whereas those that become subordinate, they continue to have very low levels of receptors. And lo and behold, those that become dominant do not take cocaine, are protected. The levels of receptors are protecting them against taking cocaine. But those that become subordinate do not. They take high quantities of cocaine, illustrating how an isolation environment can, in a child, I mean, these are children and monkeys, can actually increase their vulnerability. So let's go to next slide. So how do we address this? Well, first of all, knowledge is fundamental to understand the mechanisms, to understand the diversity. Because we know that not every child that is born into an adverse environment ends up more vulnerable to become addicted. And we also know that children that are born in very supportive environments can become addicted. So we need to understand that diversity of humans so we can start to learn better how to tailor prevention interventions, such that each child has the greatest likelihood of success. And this is why we launched, in partnership with other institutes at the NIH, including the Alcohol Institute, the Adolescent Brain Cognitive Development, ABCD study, which is a study of close to 12,000 children 9 to 10 years old that are being regularly evaluated to monitor their brain development, their exposure to drugs, their family structure, the characteristics of their school, their performance, their physical activity. to dwell into the complexity of what the social environments are and how they are affecting our brain. Now, the study was started a little bit more than 3 years, and we already have some really dramatic data that corroborates what we had known in the past, but with a much greater depth. And the next slide shows it. First of all, socioeconomic factors are one of the most important in a negatively low socioeconomic factor affecting the developmental structure of the human brain. To the left, actually, when one speaks about socioeconomic factors, one has to realize that there are multiple elements that are actually linked with that. So you have low family income, you're likely to live in a neighborhood where you don't have access to physical open spaces, where the school quality is much lower, the healthcare quality is much lower, the supermarkets don't contain healthy food. So it's not just the family income, but the environment that places you there. And in this particular study to the left, they show that neighborhood deprivation actually significantly negatively influence the morphology, the development of the prefrontal cortex, as well as impairing neurocognition, which again is not surprising because the prefrontal cortex is fundamental for cognitive operations. The other thing that is very notable as we address the issue of how to tackle prevention and the importance of addressing and personalizing it is that these effects actually of socioeconomic deprivation are negatively impacting and exacerbating other adverse stimuli. In this case, to the right is a study that actually shows how exposure to lead, which we have known all along, negatively impacts cognition. But what they do, and that's the upper part of the slide, where you see in yellow the level of lead exposure as a function in yellow, the kids that come from low socioeconomic backgrounds versus the white intermediate versus the blue high economic backgrounds, and years of lead exposure. And you see that the adverse effects of lead exposure are only in cognition observed in those in yellow, those that have the low socioeconomic background. And exactly the same findings were observed by their researchers when they look actually at brain morphology. It is the kids that are in low socioeconomic backgrounds in whom the longer the exposure to lead, the greater the atrophy of their brain. And again, it's a notion of if you have one insult, exposure to another insult is going to be exacerbating the negative effects. And so how do we then, in considering these complex issues, address prevention? And the next slide shows a very simple prevention slide, and it's simple because it is the basic principles, and they have been shown to actually work. The way that you address prevention is actually mitigate risks associated at the level of the individual, the family, of their community, while at the same time enhancing factors that will improve the resilience in the individual, that will improve the parenting skills of that family, and that will provide a stronger community support, including better education at schools. So what do we know about this? We know we don't need to do any more work, actually, that these prevention interventions, there are several of them, that decrease risk and enhance protection work. And they work at the individual, at the community, and even at the generational level. Let's look at the next slide. The next slide is a study that was done in African Americans, and it evaluates prevention intervention, the supportive parenting intervention, which was given to 59 and versus control. And it's evaluating how this intervention can mitigate the effects of poverty on brain development. And I showed you just in the slide before how poverty negatively affects brain development. And what they show in this study is that an intervention that was targeted both to the parents and the children who were then followed, who were sixth graders, who were then followed into young adulthood, prevented the reduction in volumes of the amygdala and the hippocampus, which are limbic areas important for memory and emotion, whereas those that did not receive the intervention, which are the dashed lines, actually showed the reduced volume as a function of years of poverty, indicating that, yes, prevention interventions can mitigate and buffer the effects of poverty, the negative effects in the brain. And they also mitigate the adverse effects on behaviors. So in the lower panel is the same supportive parenting intervention in African Americans, and they are looking at two outcomes, BMI for obesity and drug taking. And what they see is that different from girls who were brought up in poverty with no intervention, which you see in blue, who have a significant increase of becoming obese, those that were given the supportive parenting intervention, despite having come out of an impoverished environment, did not increase the risk. And the same thing happened with respect to substance use disorders in boys, whereas boys that were brought up in a poor environment with no intervention have an increased risk of taking drugs when compared with those that did not have that environment. The intervention prevented that transition. So this is at the individual level. You are seeing not only is it improving the brain morphology, it is also decreasing the risk for the individual for adverse medical conditions like obesity or for substance use disorder in boys. The next slide actually shows the effect of these prevention interventions at the community level. And this is a study that evaluated the impact of the communities that care in Pennsylvania, which was implemented broadly in 388 school districts, of whom 52% implemented the communities that cares, and for controls, they used those that did not. And then they followed them at the population level. And they show that overall as a population, they see much lower rates of drug taking, whether it is alcohol, cigarettes, marijuana, any drug use or being arrested or even being arrested. And they also show beneficial effects for decreasing the incidence of mental disorders. And the final one is one that I showed because it also indicates prevention works not just at the individual population level. It actually, the next slide shows an intervention that, yes, that's perfect, that actually can have a beneficial effect generationally. So this is a prevention, the Raising Healthy Children intervention, which was given to 72 children, grades 1 to 6. And then they follow the outcomes of the children of these children. The intervention, Raising Healthy Children intervention, is a multi-pronged approach. It intervenes when these children are grades 1 to 6 in the child, in the parent, and in the school. And then they actually follow them through. They have reported that children that received it have better outcomes. But now their new paper recounts on these children of the children who are now young adults. And what you can see is that individuals that this third generation, it's the third generation, the parents, the child receives the intervention, and then their children. Those in red who receive the intervention have stronger emotional skills, stronger academic skills, and stronger cognitive performance. Much lower levels of drinking alcohol or trying any drug. And look at the lower one, much lower levels of oppositional defiance, conduct problems, ADHD, affective problems, externalizing disorders, internalizing disorders. This is the third generation, the children of the children that were targeted for that prevention, indicating that prevention works, and it has a huge impact. And as you read the discussion from this particular paper, I mean, one of the potential beneficial effects about why you're seeing these long-lasting beneficial effects is because you are improving the educational attainment of those children that got the intervention. And so they are able to grow up and find jobs and have higher incomes. And so their children are able to go to better school, have more support. So you can see how this intervention, by addressing socioeconomic disparities, can profoundly affect the outcomes in these children. So this is what we know. And as I say, the data is very, very strong. And I would want to ask us the question, I mean, we know all along that it works. So the question is, why are we not implementing it? I mean, we show that it has benefits for individual, population, and generation. So why are we not implementing it? And what is ahead of us? And again, I'm bringing it up because I think that we have to be very aware that in the next slide, where I show how the COVID pandemic moved the pressure, the COVID pandemic, which is really like a tsunami, is taking the country amidst already an epidemic of substance use disorders that, of course, started with the opioids, and we now know is exacerbated by psychostimulants. So how are these factors basically challenging? I mean, the epidemic is being challenged, but as it will relate to the younger generation and the risk of taking drugs. Well, we have to be aware, and I want to highlight just one point, the next slide, which is what the epidemic has done, the pandemic has done. It has infected, I mean, depends on which area of the country you are. In some places, maybe 10%. I mean, in others, much lower. But every one of us has been affected by the anxiety, the uncertainty, the distress of seeing others suffering. And that in and of itself is a risk factor for taking drugs. And we know that. Now, that is particularly negative for adolescents. And so now I have a slide that says your presentation is scheduled to end in 5 minutes. So please, can I have the next slide? I've seen it. I am going to end up shortly. So my next slide is that if I'm not seeing it, but if it's there, what it shows is that probably one of the most devastating effects in terms of the risk for drug taking and the risk for relapse relates to social isolation. And this pandemic has actually interfered with our ability to interact with others in a closer way, to have meaningful interactions. Yes, virtual technologies are helpful, but they are not the same. And we need to recognize that social isolation, which has been shown for many, many years, and that's what the slide was showing, how dramatically it influences the rate at which animals take drugs. So it's not just about animals. We know that humans are very, very vulnerable. We know that isolation is one of the factors that leads to the greatest vulnerability as it relates to the propensity of wanting to experiment with drugs. And if you experiment with drugs, the propensity to escalate. And if you are already addicted, the risk for relapse. So as we look forward with all of the challenges that we have with the pandemic, we need to recognize as we mount the importance of prevention interventions, that we are in a particularly vulnerable period, but that with prevention, we can help protect children, young adults, and the adult population in general from substance use disorders, but also for achieving a greater sense of well-being. Thanks very much for your attention.
Thank you, Dr. Volkow. I understand that you may have another commitment at 11 o'clock, so I wanted to ask if you had a few minutes for questions or if you need to leave. We want to be respectful of your time.
I need to leave in 3 minutes, so if there's a question, I'm happy to answer it rapidly.
Okay. The very first question that came in was, Dr. Volkow, do you think the legalization of marijuana for recreational use plays a role in higher use amongst young people because of the normalization of the drug?
Indeed, and the study and the data shows that. I mean, as the more a person feels that the substance, if they have the sense that the substance is not harmful, that it can have medical purposes, that it has been legalized, and therefore it cannot be so bad, the greater the acceptance of that drug, the greater the likelihood that teenagers will get exposed to it. And so adults too. And there's actually, and we're seeing it. We're seeing it, the increases in regular patterns of consumption of marijuana. And we're also seeing there's very scary increases in the vaping of high content THC. So yes, the answer is yes.
Dr. Volkow, thank you so much. And I want to thank you for your overall presentation. It was extremely informative and thoughtful and really took us through all those dimensions of neurobiology and the environmental and social determinant contributions. Thank you for that. Just wanted to conclude and let you know that many people are singing your praises here on the Q&A box, and just wanted to share that with you. Many people thank you for your words today.
Thanks for giving me the opportunity to share it with everyone.
Absolutely.
Bye-bye.
Bye. Have a wonderful day.
Thanks. Bye-bye.
All right. At this time, with your permission, we'd like to actually eliminate the break that we had scheduled between 11 and 11:15, since we took an impromptu break a little earlier before Dr. Volkow's presentation. So I'm going to hand it over to Jamie.
Thank you, Laura. It is my pleasure now to introduce you to ONDCP's Deputy Director, Art Kleinschmidt. Prior to joining ONDCP, Deputy Director Kleinschmidt served as the Senior Advisor on Substance Abuse to Assistant Secretary for Substance Abuse and Mental Health Services, SAMHSA, at the U.S. Department of Health and Human Services, HHS. As a person in long-term recovery, Dr. Kleinschmidt comes to this position with a vast real-world experience and education in the field of addiction treatment. He earned a master's degree in addiction counseling and completed his clinical training at Hazleton Betty Ford. Dr. Kleinschmidt has been immersed in the recovery community and possesses a vast array of clinical experience working with a multitude of clients, including gang-affiliated incarcerated adolescents in Minneapolis. He has experience working with dual disordered clients, is skilled in multiple modalities, and owned and operated an outpatient treatment center for criminal justice clientele. In addition, Dr. Kleinschmidt has earned an MBA, is certified as a trauma treatment, and is a licensed professional counselor, licensed addiction counselor, and a licensed drug and alcohol counselor. Please welcome Deputy Director Kleinschmidt.
Good morning, everyone. It's a great pleasure to be speaking with you today. And as the newly appointed by Deputy Director for Office of National Drug Control Policy, I have to say it's a great honor to be serving President Trump in this position. We know that if a person does not begin using drugs before the age of 18, it is unlikely that they will start using or develop problems with substance use disorders later in life. In my clinical experience, this actually holds true. And I do want to echo the sentiments of Dr. Volkow when she talks about ACEs, adverse childhood experiences. And a lot of times in the treatment world, these are what we're addressing within a clinical format within treatment. Rarely have I seen somebody who developed an addictive disorder later in life. It's generally something that happens in adolescence as the disease progresses into adulthood. That is why your work is so important to the health of our nation. As you heard this morning from from Director Carroll, the Office of National Drug Control Policy supports prevention activities and programs through a coordinated approach by federal, state, local, and tribal law enforcement and community stakeholders for the dissemination and implementation of efforts that are key in alleviating the impact of drugs on communities across the nation. We know from research that preventing drug use is the most cost-effective, common-sense approach to promoting safe and healthy communities. It's important to note that public health and public safety partnerships build smart, common-sense strategy that fosters coordination and collaboration and makes efficient use of limited community resources. By connecting multiple sectors of the community, these partnerships can achieve real outcomes. Building a prevention infrastructure at the local level is key to achieving public health, drug reduction, and discouraging initial use. Thank you all for what you do to keep this nation safe, resilient, and healthy. I look forward to our continued work together.
Thank you, Dr. Kleinschmidt. At this time, we are going to experience a brief pause as we transition between the sessions and move on to our panel with the Centers for Disease Control.